The James Webb Space Telescope has just captured one of the most spectacular stellar outflows ever seen, a young, massive star blasting twin jets stretching 8 light-years across space. This discovery not only shows us how stars are born, but also offers a rare glimpse into what the early universe looked like. The new image, taken with Webb's near-infrared camera, shows a young star embedded within the nebula Sharpless 284. From deep inside its cocoon, the star is firing 2 enormous jets of gas at hundreds of thousands of miles per hour. These beams slam into the interstellar medium, creating glowing shockwaves and sculpting the nebula into a breathtaking structure. The length? About 8 light-years. That's nearly 50 trillion miles. Jets like these are a normal part of star formation. Here's how they work. A young star pulls in gas and dust, forming an accretion disk around it. Most of the material spirals inward, feeding the star, but magnetic fields channel some of the excess gas outward into tightly focused jets along the star's poles. This process prevents the star from swallowing too much material too quickly. It's almost like a cosmic pressure valve. Jets are common in low-mass stars like our Sun once was, but for massive stars, the story is trickier. Some theories suggested that the growth of giant stars was chaotic, their disks wobbling, their jets twisting and spraying across space. But Webb's image shows these jets are straight, stable, and precise, almost 180 degrees apart. That means even massive stars can grow in an orderly way, just like smaller ones, overturning decades of assumptions. By measuring the length and energy of the jets, astronomers estimate the hidden star is at least 10 times the mass of the Sun, and still growing. The tips of the jets are the oldest parts, launched over 100,000 years ago, while the inner knots trace more recent outbursts. It's like reading the star's diary, written in light and gas. This newborn giant lies 15,000 light-years away on the outskirts of the Milky Way. Out here, the environment is poor in heavy elements, what astronomers call low metallicity. That's important because it mimics the conditions of the early universe when the first stars were forming. Studying the star is like opening a time capsule, helping scientists understand how the first massive stars were born billions of years ago. This star won't live long. In just a few million years, it will likely explode in a supernova, seeding space with newly forged elements: oxygen, carbon, iron, the very building blocks of planets and life. For now, its colossal jets mark the dramatic beginning of its story. But eventually, its violent death will enrich the galaxy, fueling the birth of future stars and worlds. Discoveries like this remind us that we're watching the cosmic cycle of life and death in real time. Webb isn't just showing us beautiful images, it's answering questions about how stars grow, how galaxies evolve, and even how the ingredients for life get spread across the universe. What do you think is more awe-inspiring, the birth of a massive star, or its explosive death as a supernova? Let me know in the comments below. And don't forget to like, subscribe, and hit the bell for more cosmic discoveries from the James Webb Space Telescope.